Hello friends, today we will discuss trick to find expectation value of momentum by the method of Baker-Hausdorff Baker-Hausdorff relation. Actually, we will solve a problem that has come to the exam of JEST 2012. JEST 2012. In that problem, by discussing that problem, we will discuss important theory of the Baker-Hausdorff relation. Baker-Hausdorff relation, and by which we will solve that problem within few minutes. So let's start discussion. So what was that problem? The problem was such that momentum expectation was given in the state ket psi x. Psi function of ket, it is a predefined state. So it was a predefined state, ket psi x, and the expectation value of momentum p is given such that p equals psi p ket psi. Now it was asked in the question that what would be the result if another state is such that e to the power I kx psi x, means they are actually trying to ask what would be the expectation value of momentum if the state is such that e to the power minus, in the Brash state, what we know, the Brash state complex conjugate is happening, so e to the power minus ikx psi x p e to the power ikx psi x. This is a thing we know. Then what would be the result? So before discussing this thing, we have to know an important relation, that is Baker-Hausdorff relation, that is known as, what was that relation? E to the power a, an operator a and b, they are such that e to the power a, another operator b, e to the power minus a. Then what is the relation? The relation is such that b operator plus 1 by 1 factorial a comma b. Sorry, let me write the formula clearly. So formula is e to the power a b e to the power minus a, that would be b plus 1 by 1 factorial commutation relation a comma b plus 1 by 2 factorial another commutation relation a comma commutation b plus dot 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 so on. So we will apply this formula. In this case to find the expectation value of momentum in the state e to the power I kx psi x. So what is the result? Now let us consider this in state ket phi x. So bra phi x p ket phi x. So what will be the result? So we can write it in such a way that e to the power minus ikx psi x p hat e to the power, let me write clearly, p hat, now e to a hat psi x again e to the power plus ikx. So we can write in such a way, we can see that this thing is what? We can see that this thing is known as expectation value of momentum. So we can write clearly in such a way that we can write it e to the power minus kx expectation value of p operator, x is an also operator here, p is an also operator, plus e to the power plus ikx. Or another form we can write e to the power minus ikx minus ik in bracket p operator e to the power minus ik into x. So this is the thing. So now compare it with e to the power a, b, e to the power minus a. Okay, compare e to the power a, b, e to the power minus a. So comparing it, what we will get? A value is minus ik, b value is p. So we can write it in such a way that e to the power a, like let me write clearly, e to the power a, b, e to the power minus a. It can be written as b. Only two terms I will write, only that is needed here. 1 comma 1 factorial a comma b, this commutation relation. So comparing that, we can write e to the power minus ikx, expectation p, e to the power plus ikx. So we can write expectation p is written as here. It is if we compare it, then expectation p will be b, and x sorry ik minus ik is written as a. So this is a trick to we can solve easily. P plus, so ik is outside, ikx minus ikx, this will be sorry minus ikx, this whole as a whole will be a. So we can write here, we can write another place in fair place, e to the power minus ikx, p momentum to the power plus ikx. So p momentum here it is coming, and minus ikx if a, then 1 by 1 factorial minus ikx comma p, commutation relation. So now we have to solve this commutation relation minus ikx comma p. So what is the result of this commutation relation minus ikx comma p? Let me write minus ikx comma p. X and p are x and p are what? X and p are the operator. So minus ik is outside. Then we can write x comma p. X comma p has known commutation relation, that is I h cut. So minus ik into I h cut. Okay. Now h cut here I minus I into I. That means minus I square h cut k. And one important thing is that is, so one important thing is that you have to remember this commutation relation x comma p, that is I h cut k. So you are getting the relation as equals h cut k. But in the question, sorry, little bit mistake of writing that question. In the question, it was actually, the question was on the state e to the power I kx by h cut into psi x. It was actually the question, divided by h cut also there. So in the actual question, if we write again e to the power minus I kx by h cut psi x p psi x e to the power ikx by h cut. So you can write here clearly p vector plus h cut k divided by h cut will be also there, because in that case minus ikx by h cut will be the a, and p will be the expectation value of p. This thing will be remaining as b operator. So h cut cancel out. So result will be p plus k. So this is the important formula by which we can solve any problem within few minutes. So I'm writing the things that we have learned, the important formula we have applied here, that is e to the power a, b, e to the power minus a. It will be written as b plus 1 by 1 factorial a comma b plus dot, it will go out. So this is the important thing by which we have solved the relation of momentum expectation value. So that is it for today. Thanks for watching patiently. Bye.